Good morning, student. Welcome to the online series of computer graphics. Today we are going to discuss the topic in unit number 6, the curve. So in computer graphics we often need to draw the different types of object on a screen. The object are not flat all the time and we need to draw the curve many times to draw an object. For example, if you want to draw a circle, you can draw the circle with the help of a number of segments, and those segments will be termed as the curve. Now we will discuss the type of curves. The curves is indefinitely large set of points. First thing. Second, each point has two neighbors except their endpoints. On the basis of these 2 points, we are having the types of curve as explicit curve, implicit curve, and the parametric curve. So when we are talking about the implicit curve, it means what? It means what? Whenever we are having the control points, my curve is passing through those points, and that curve is known as my implicit curve. It is represented by f of x comma y equals to 0. Now what is the explicit curve? When we are talking about the explicit curve, the explicit curve is what? One, the curve is not passing through the actual control point, and it is represented by the function y is equal to f of x. Now, as far as our syllabus is concerned, this parametric curve play an important role because we are going to learn the two basic types of curves, that is Beeb's line curve and the Bezier curve, which are based on this parametric curve. So what is this parametric curve? So parametric curve is representing the function by x of t comma y of t. In case if it is 3D, then z of t will be there. So what is this t? So t is ranging from 0 to 1. I will show you few types of curve, Bezier curve. So Bezier curve. What is this Bezier curve? So Bezier curve is defined by the control points. Now what is this control point? So P0, P1, P2 are the control points. If we are having two control points, then my curve is known as my linear curve. In case if I am having three control points, then my curve will be known as quadratic curve. So my case 1 or a figure A is what? It is the quadratic curve. Now we will see about the second one. How many control points are there? P0, P1, P2, P3. 4 control points are there. So this is nothing but my cubic curve. Now if you observe over here, if you are having 3 control points, then it is the degree n minus 1. So how many points are there? 3 control points are there. So n minus 1, so 3 minus 1, so it is quadratic. How many control points are there? 4. So what is this? The control point is 4. So degree is n minus 1. So 4 minus 1, so it is cubic curve. Getting everyone? Now the points are not always on the curve. Always remember this point. The points are not always on a curve. The curve order equal to the number of control points minus 1. If you observe this P1, P2, these 2 points are known as the handle points. P0, P3, P0, P3, that is nothing but the starting and the ending point of a curve is known as the anchor curve. Now we will see the property of a curve, Bezier curve. They always pass through the first and the last control point. They are always in a convex hull of defining control points. The degree of polynomial defining the curve segment is 1 less than the number of defining control points. The control point, for example, if we are having the 4 control points over here, then the degree will be n minus 1. Then my curve will be known as it is a cubic curve. The shape of defining polynomial is usually followed by the Bezier curve. The Bezier curve are tangent to their first and last edge of the control point. Now we will see in detail the Bezier curve. The Bezier curve is represented by P of u. P of u, the Bezier curve is mathematically defined by this function. P of u is equal to summation of I is equal to 0 to n pi bi comma n of u, where u is in range of 0 to 1. Whereas in case this bin of u are nothing but a blending function, which will we see in detail. Also, so how we are going to represent this function? So this function is represented by bin of u is equal to c of ni ui 1 minus of u and to the power I, where c of ni is nothing but the binomial coefficient. Now binomial coefficient can be represented by the n factorial by n minus I factorial into I factorial. If we are going to expand this particular equation, we will substitute this thing in our equation. What is our equation? It says that P of u is equal to summation of I to n bi n of u. So we will get the expanding function as P of u is equal to b0 p0 b0 n. Why it is now I is represented by 0? So u plus pi bin of u up to n. Now see, if we are considering that the value of my n is 3, so I is equal to 0 to n, so my n is 3 over here, so I will represent it as p0 b0 3 of u plus p1 b1 3 of u plus p2 b2 3 of u and up to p3 b3 3 of u. Now we have to express this blending function. Okay, so blending function is nothing but it is in the binomial form, so we will write it where b0 of 3 of u is c, what is that? It is n factorial by I factorial into n minus 1 factorial. So what is your n? It is 3. What is your I? It is 0. So n minus 1. So we are having this u to the power I. What is the value of I? It is 0. Now we are having I minus u to the power n minus 1. So we are having for b0 3 of u is represented by 1 minus u to the power 3. Now similarly we will calculate the b1 3 of u. It will be represented by 3u 1 minus u to the power 2. b2 3 of u, it will be represented by 3u square 1 minus of u, b3 3 will be represented by u3. Now we will put all this blending function value in the above equation. So we will get P of u is equal to 1 minus of u to the power 3 p0 plus 3u 1 minus u to the power 2 p1 plus 3u square 1 minus u p2 plus u cube plus u cube p3. Now if we are taking all the p0 points, so we will get, if you are solving this, we will get the 1 minus of u to the u minus u cube plus 3u square minus 3u plus 1 p0. So what is this p0, my dear student? The p0 will represent px and py in case of two dimensional. In case of 3 dimensional, so P0 will have Px value, Py value and Pz value. So here we are having 3 plus 3u cube minus 6u square plus 3u plus of Pm1 minus 3u cube plus 3u square P2 plus 3u cube P3. This can be expressed by this matrix form. P of u is equal to f of b, where your f is nothing but the t and m. So what is b? So we are having this control points P0, P1, P2, P3. T is what? So these are nothing but my degrees. So U3, U2, U1, my Bezier function. So it is my M. M is represented like this. So what is this now? From where we are getting minus 1, 3, minus 3, 1. So see 1, getting everyone? Minus 1, 3, minus 3, getting? So 3, minus 6, 3, minus 6, 3. So this is my Bezier matrices. So when we are having the control points, okay, in Bezier curve with the degree as 3, we can use this matrices and we can put the value of here. If you are calculating the Bezier curve, then first we have to put all the values of x. So P0 x value, P1 x value, P2 x value, P3 x value. So we will get the value of Bezier curve for x, then we will calculate the value of y. Now we will see one numerical. So construct the Bezier curve of order 3 and 4 polygon vertex A11, B23, C43 and D64. So the equation of Bezier curve will be given as which we have discussed previously. So P of u is equal to 1 minus u cube P1 plus 3u 1 minus u square P2 plus 3u square 1 minus u P3 plus u cube plus P4. Now here we are representing the points as P1, P2, P3, P4, where our u is ranging from 0 to 1, where P of u is the point on the curve. If we are talking about a two-dimensional, yes, this problem is related with the two-dimensional because the points are represented into x and y format. Let us have the value of u. You have to define or you can decide the value of u. So here I am considering the value of u as 0. Always starts with 0 and ends with 0. You can have the any value in between of 0 and 1. You can choose any value. So here I am choosing the value as 1 by 4, 1 by 2, 3 by 4 and 1. So P0 is equal to P1 1 1 by substituting those values. P0 is equal to, see, P0 means what? Here I am putting the value of u as 0. So I am getting what? P1 is equal to 1 comma 1. 1 comma 1. My dear student, try to understand what is my first point. It is 1 comma 1. Always remember, whenever we are talking about any curve, my first point and last point will remain as it is, because my curve starts from starting point and ends with last point. So here my first point is having 1 comma 1. Now I am putting the value of u as 1 by 4. If I am putting the value of 1 by 4, I will get this value. It is what? 1.9, 2.7. 2.117. If I am putting the value as 1 p value of u as half, then I am getting the value as 3.12, 2.87. U value is 3 by 4, then I am having the value as 4.5, 3.3. Value of 1, try to understand this. value of 1, u is 1, so I am getting the last point as what, d is 6 comma 4, so I am getting the value as 6 comma 4. So calculate this, you will get the same thing. Thus, calculating all the points of Bezier curve, we have to plot all the points. So my first point is what, 1 comma 1, the second point is 1.9 comma 2.1. Getting everyone this? Then we are having 3.1 comma 2.8, then we are having the second last point as 4.5 comma 3.5, and the last point is 6 comma 4. So you have to plot this curve as well. So if you are having any doubt, you can ask me the question related with the Bezier curve, and note down your second question. This is your assignment question. Find the equation for the Bezier curve which passes through the following points, and control points are given like this. Thank you, my dear student, for listening.